In this section, I am going to be discussing limits involving infinities. So, first off, we have to know what the different functions are for limits involving infinities. So, let's say we have x, 1 over x. This is going to give us 0. Reason being that if you have 1 over 10, 1 over 100, it's just going to be how long it takes before it actually reaches 0. So you have 1 over 10 would be 0.1, 1 over 100 would be 0.01, and then we have 1 over 1,000, it's going to be 0.001. Now what if we vice versa, we have the 0 inside, then we're going to have plus or minus infinity, because if it approaches from both sides, it's either going to go all the way down or all the way up as it approaches 0, or how long it takes to get to 0. Now, if we do any type of math with infinities, we will see that a number times an infinity will equal infinity. Infinity divided by a number would equal infinity. And infinity times divided by infinity would give us an indeterminate, because you can have any number in that spot, 7 over 3, 7 over 7, or 3 over 7. You don't know what's going to be in that function, so it's indeterminate. Using this rule, we're going to do with infinities using degrees. So if we have degrees with the same value, for instance, we have a limit of x approaching infinity. We have a degrees which is the same with 3x cubed plus 2 squared and 4x cubed plus 1x. We're going to look at the two of the biggest degrees, and we're going to see that we have both of them top and bottom. And the degrees would be 3 for the top, and the degree on the bottom would equal 3. And we're going to come back to that and see what the results is. If we have the limit of x approaching infinity, and we have the degree on the bottom bigger than the degree on the top, plus 3x plus 4, this one's going to equal 0. But if we switch it over and then limit x approaching infinity, and then the degree on the bottom, degree on the top now, 5x, it's bigger than the degree on the bottom, 3x, this is going to give us infinity. Let's look at what happens when we apply the rules to this equation. So limit of 3x cubed plus 2x squared over 3x cubed plus 4x as x approaches infinity. If we separate these using the first rule, the quotient rule, we're going to have 3x cubed plus 2x squared as x approaches 0, infinity, all over limit of x approaching infinity over 3x cubed plus 4x. Now, when we look at this, we see that we have the degrees which are the same top and bottom, and they're both. So what we're going to do is we're going to use the degree, which is the highest, and divide it by the whole numerator and denominator. So we're going to have 3x cubed over x cubed plus 2x squared over x cubed all over 3x cubed over x cubed plus 4x over x cubed. And remember, we still have the limit of infinity, x equals infinity. So if we look at this further, we see we could cancel out the x's for the first one, and this one, the x will go to the bottom and cancel out for the second one. So we're left with limit of x approaching infinity of 3 plus limit 2 over x as x approaches infinity all over limit 3 as x approaches infinity plus limit 4 over x squared as x approaches infinity. And this could be broken down even more to limit of 3 as x approaches infinity plus 2 from our constant multiple rule. We know that's 2 limit over 1x as x approaches infinity. And then we're going to do it for the bottom as x approaches infinity plus constant multiple rule again, limit of 1 for x squared, x approaches infinity. We know that this is going to be 0 because this is just going to tell us how long x is going to approach 0 faster. So we see that 3 plus 2 times 0 is going to be 3 plus 4 times 0, which is going to give us 3 over 3, which is equal to 1.